So ang topic natin ngayon is we have part 1 and part 2. So for part 1, we have shear design in flat plates and flat slabs. And for part 2, we have a wall and column footings. So for part 1, ayan. Oops, what happened? Excuse me. Okay, so may tanong dito, what is shear in slab? So actually, we are talking about the punching shear in slab, no? So itong figure na to nakikita nyo dito, itong column, and ito yung portion ng slab. So this is an example of a flat plate slab. The slab is monolithically constructed with the column. So originally ang slab is nandito siya, but then due to the applied loads, so nagkaroon ng punching hole and yung slab ay bumaba siya, no? So this is due to the reaction also of the column on the slab. So itong portion na to ng slab, ito yung tinatawag natin critical region for punching shear. And in order to minimize the occurrence of punching shear, no, kailangan ang ating design shear strength for the slab should be adequate, or it should be greater than the ultimate shear or the VU para ma-resist niya yung punching shear. So that's the purpose na kailangan maglagay tayo dito sa portion na to ng slab near the support, no, or near passing through the support. Kailangan tayo maglagay dito ng shear reinforcement on the slab, no, in both directions. So merong bars na ilalagay dyan, no, kung ilang bars yan depende sa calculations, and another bars in this direction, no. So kung this is north-south direction and east-west direction, so we will have we will provide reinforcement bars in the east-west direction and also in the north-south direction. Okay? So yan yung purpose na kailangan nating mag-design ng shear strength, no? Then before anything else, so let's try to be familiar with the tables na kailangan natin gamitin. So we have here the factor shear in slab systems with beams. So ito namang table 810, 81 is, it shows here the distribution coefficient of shear resisted by beam. So depende yan sa value ng L1, L2, L1. Kung 0 yan, is 0 din yung distribution coefficient. If this term is greater than or equal to 1.0, then the coefficient here is also 1.0. Then in this figure, it shows here the tributary area for shear on an interior beam. So kung ito yung ating interior beam, so ang tributary area set by this interior beam is actually, so itong dalawang trapezoidal area on this span and also in the other span. So meron pa tayong similar figure mamaya. Then, in addition to shears calculated according to 810.81, no, yung table kanina, beams also shall resist shears caused by factored loads applied directly to the beams, including the weight of the beam stem above and below the slab. So calculation of required slab shear strength based on the assumption that load is distributed to supporting beams in accordance with 810.81. So shear resistance to total VU occurring on a panel shall be provided. So ito na yung sinasabi ko kanina na there should be a shear resistance to the total VU. So ang ating shear design strength should be greater than the VU in order to resist the punching shear. Then we have here figure 13.13 showing the tributary areas for shear calculation. So for beam CD, we have here the tributary area, no? Dalawang triangle. And for beam BD, we have here the two trapezoidal areas on this span and in the other span. So we have two trapezoidal areas for beam BD, and this is for the two-way slab. Then for the single leg stirrup or bar, so ang length na to is equal to 6 times the bar diameter or a minimum of 75 mm. Then the maximum angle here is up to 45 degrees. Then ito namang length na to is you just check section 25.3 of the ACI code. And for letter B, we have the multiple leg stirrup or bar. So kung ito yung ating top bars, then we have this bottom bars. So ganito yung magiging arrangement ng multiple leg stirrup or bar. Then for the closed stirrup, so kung ito yung ating top bars and bottom bars, so yung 4 bars dito are enclosed by this stirrup and another 4 bars enclosed by another stirrup. Okay. Then for this particular figure, suppose this is the beam, no? Beam in the east-west direction, north-south direction, and another beam in the north-south direction because this is an interior column. So ito yung critical section through slab shear reinforcement. So ito yung sinasabi ko kanina doon sa first figure na nakita nyo. Ito yung region for the critical punching shear, no? So kailangan or it occurs at d/2 or a distance of d/2 from the face of the support. So sa lahat ng directions or in all the sides on the column. So we have here d/2, d/2, and d/2 so that the total length here is the size of the column or the width of the column plus d/2 plus d/2. So if this is a square column, so the all sides are equal. So to measure, you measure this one length and multiply this length by 4 to get the total perimeter of this critical shear region. And the spacing of the stirrups here is d/2, and also in this north-south direction is again d/2. So looking at the elevation of the slab and column joint, no? So our effective depth is from the surface or the surface of the concrete to the center of the bar cross section. And the spacing of the stirrup from the face of the column is equal to or less than d/2. And the rest is also less than or equal to d/2. Okay. So itong stirrup naman na to, this is the development level of the stirrup, no? Itong stirrup dito sa ating north-south direction na beam, which is also equal to or less than 2 times the effective depth. Then for the slab edge, so ito yung ating beam, no? Then we have this beam. So ang ating column dito is nasa edge siya ng slab, no? So this is again the critical region, critical section, which is a distance of d/2 from the face of the column, d/2 and d/2. So that the total perimeter is this length dA plus AB plus CB. So that will be the BO or the perimeter of this critical region. Then showing the elevation, no? Ito yung column and beam joint, no? So nakikita nyo dito, ito yung stirrup ng beam na yan. Then ito naman yung stirrups ng beam in this direction, no? So as you can see, no, yung development length ng top bars ng beam is extended to the support. So depending on the calculated development length plus it is bent with a hook. So ganun din sa bottom bars, it is also bent with a 90-degree hook. Then yung ating stirrup here is less than or equal to 2 times the effective depth. Then for slabs supported by columns having a ratio of long to short sides not greater than 2, tests indicate that the nominal shear strength may be taken equal to this equation 13.11a. So we have here, this is in English unit. So according to ACI, ang BO is the perimeter along the critical section and lambda is the lightweight concrete factor. So usually sa mga problems, ang lambda na ginagamit is for normal weight concrete. So kung hindi given ang lambda, you just assume that the concrete is normal. So you use lambda equals 1. However, for slabs supported by very rectangular columns, the shear strength predicted by equation 13.11a is unconservative. So according to TESS, the value of this VC approaches this expression as the beta or the ratio of long to short sides of the column becomes very large. So reflecting this test data, the ACI code states further that VC in punching shear shall not be taken greater than equation 13.11b. And the variation of the shear strength coefficient as governed by equations A and B is shown also in figure 13.22 as a function of beta. So tingnan nyo na lang doon sa reference yung figure 13.22. Then further tests reported have shown that the shear strength VC decreases as the ratio of critical perimeter to slab depth or BO over D increases. So accordingly, the ACI code states that the VC in punching shear must not be greater than this equation 13.11c, where AS is 40 for the interior columns, 30 for edge columns, and 20 for corner columns. So example here, columns having critical sections with 4, 3, or 2 sides respectively. So that's according to the ACI code, the punching shear strength of slabs and footings is to be taken as the smallest of the values of BC. So yung tatlong equations kanina, no, 13.11a, B and C, so yung pipiliin ninyo is the smallest value of BC. The design strength is taken as BC times the reduction factor, where our reduction factor is equal to 0.75 for shear. So ang basic requirement dito is that the VU should be less than or equal to the design shear strength. So for columns with non-rectangular cross sections, the ACI code indicates that the perimeter BO must be of minimum length but need not approach closer than D over 2 to the perimeter of the reaction area. So meron tayo ditong irregular shape, no, for the support dito sa figure 13.3. So ito yung ating figure 13.23. So inverted L yung shape ng ating column. So again, the critical perimeter BO is D over 2 or a distance of D over 2 from the face of the column. So D over 2 rin dyan. D over 2 rin dito, D over 2, and also here, no? This is also D over 2. So, you just connect the dots, no? So that the total perimeter here is this length plus this length, and this length plus this one, and so ilang sides lahat? 1, 2, 3, 4, 5 sides lahat. Yun yung inyong compute na perimeter. So, ang beta here is the ratio of A over B. So, ang A natin is the distance from this corner to that corner, no? Ito yung A. And then, ang B naman, this is a line perpendicular to A. So, from this corner to this line dito. Yan yung ating B. Then, dito naman tayo sa design of bent bar reinforcement. So where inclined shear reinforcement is all bent at the same distance from a support. So ito yung ating equation. So we have here Vs equals AV Fy sine alpha. And this expression should be less than or equal to this maximum Vs. Then the required area of reinforcement for shear AV is equal to Vu minus Vc times the reduction factor over Fy sine alpha times the reduction factor. So this is equation 13.12. Now let's try to solve yung sample problem. So this is an example of design of bar reinforcement for punching shear. No? Paano ba tayo mag-design ng bar reinforcement for the punching shear? So we have here a flat plate floor, has a thickness of 7.5 inches and is supported by 18 inches square columns, spaced 20 feet on centers each way. So the floor will carry a total factored load of 300 pounds per square foot. Check the adequacy of the slab in resisting punching shear at a typical interior column. So yung titingnan natin yung interior column, no, kung ano dapat yung adequacy of the slab in resisting punching shear. Kasi ang interior column mas mabigat ang load that is carried by the interior columns, no, compared with the exterior columns, and provide shear reinforcement if needed. So, malalaman natin na kailangan natin ng shear reinforcement if the VU is greater than the shear strength design. No? Yan. So using bent bar similar to figure, this is the figure 13.20B. So an average effective depth D is given, which is 6 inches, and the material strengths are 60,000 PSI for Fy and 4,000 PSI for F Francis. So ganito ang design, no, na gagawin natin for this particular problem. So meron tayo ditong bent bars, no, ito. So sa direction, let's say this is the east-west directions because we are looking at the elevation, no? Ito yung ating column and this is our slab, no? So this is the east-west direction of the slab, and of course we also have the north-south direction of the slab. So sa east-west direction of the slab, we have this arrangement of the shear reinforcement, no? This is bent, no? Yan, ganyan. Then, for the north-south direction, we have these bars also bent in this manner then. Okay? Now, nag-prepare ako sa AutoCAD ng ganitong sketch so that makikita nyo dito yung location ng ating interior column. So, Suppose ito yung ating edge slab or exterior slab. And we have dito sa span na to, meron pa tayo mga slabs dito, no? And so we have this column here in the interior side, no? Kasi may slabs din tayo dito, no? Hindi ko na lang pinakita ng slabs dito. But hanggang dito ay merong slabs niya, no? Then the spacing or the spacing on centers between the column is 20 feet. Okay. So, ito naman na highlight na column. So, ang column cross-section natin here is highlighted in yellow color. And the one highlighted in green color is actually the critical region where the punching shear occurs, no? So, from the face of the column, meron tayo ditong D over 2 and a distance of D over 2 plus D over 2 plus D over 2. So ito na yung ating critical region, yung green, no, for the shear or punching shear. Then this is the close-up sketch, no, yung kanina. So para mas makita natin siya in detail. So ang ating column in yellow color is ilan ba yung ating column section is 18 inches. So meron tayo itong 18 inches for the column. So this is a square column. So 18 inches, 18, 18, 18. So ang kalahati ng column is 9 inches or 0.75 feet. Then meron tayo ditong D, no? D over 2, which is ating effective depth is 6 inches. Over 2 is 3 inches or 0.25 feet, no? So this is 0.25 feet and the half of the column section is 0.75 feet. So that our L2 here, so ito yung ating L2. This will be our L2. Yan. So 0.75 plus 0.25 times 2, kasali yung sa kabila. So we have 2 feet, no, for our L2. Since this is a square column, so itong length na to is also 2 feet, 2 feet, and 2 feet. Then the tributary area here is the gross, no, we have here the gross area, which is 20 feet by 20 feet for the slab, no? So we have 400 square feet. And for the L2, so ibabawas natin itong area ng ating L2 times L2. So we have 2 feet by 2 feet is 4 square foot. So the total tributary area is 400 minus 4 equals 396 square foot. So, computing first for the VU, so yung given kanina na 300 pound per square foot. Balikan natin yung problem. So, this is already a factored load. No? The floor will carry a total factored load of 300 pound per square foot. And multiply that with the total or the net tributary area, which is 396 square foot. So we have 118,800 pounds for the VU. Then computing for the VC, so we will just substitute the values, no, for BO. So we have BO. So 2 feet kanina yung BO natin, which is also 24 inches. So kukunin lang natin yung value ng ating perimeter in inches unit, no? So 24 inches since 4 sides yan, so times 4 is 96 inches. Then substitute the value in our formula. So we have this, ating reduction factor for shear is 0.75 times 4, and our lambda is 1. Then square root of f prime, so this is 4,000 times 96 inches times the d, which is 6 inches. So we have here 109,300 pounds. So ang VC natin is less than the VU. So meaning to say, kapag mas malaki ang VU natin, then our design shear strength, kasi lalagyan pa natin yan ng reduction factor, lalong delete ito. So meaning to say, hindi siya adequate, no? It cannot resist the punching shear caused by the factored load due to 300 pound per square foot. So kailangan we need to provide a combination of reinforcement and concrete. So if we use a combination of reinforcement and concrete, ang concrete contribution will be reduced to yung isang formula, no? So from 4, magiging 2 na lang siya. So ang ating VC, the concrete contribution for shear is 54,600 pounds, and the remaining will be contributed by the shear reinforcement na. So tingnan natin. So we have here the shear VS to be resisted by the reinforcement is equal to this equation. So we have VU minus VC times the reduction factor. So we have here 118,800 pounds for the VU, and then 54,600 for the this one, no? And over 0.75, so that the VS is 85,600 pounds, and it should be less than the maximum contribution for shear reinforcement, which is 109,300 pounds. So this is satisfied because this is 85,600 pounds. So we can now proceed. Now, computing for the required bar area, which is AV. So we have here the VS, no? Ito yung i-carry ng VS. So 85,600 divided by Fy times sine alpha, kasi bent kasi yung bar natin. Usually ang ating angle here is 45 degrees. So sine 45 degrees is 0.707. So our AV here is 2.02 square inch. So ito yung total shear reinforcement needed to resist the punching shear, no? Due to the factored load. So a total of 4 bars will be used, 2 in each direction. So sa north-south direction, so kung mag-drawing tayo dito ng ito yung ating column. Then somewhere here, ito yung ating critical region for the punching shear, no? So pasensya at hindi equal yung distance. Ito should be equal, no? Kasi d over 2, d over 2, d over 2, and d over 2. So pinalaki ko lang siya. So we have here for this direction, this north-south, no? Then for this direction is we have east-west. East-west direction. So ito yung ating north-south direction. So a total of 4 bars will be used. So dalawa in each direction. So there will be, palitan ko ng color. So ito yung magiging bar natin. Gagawin kong blue color. So maglalagay ako dito ng dalawang bars. Ayan. Sa direction ng north-south. And dalawang bars din sa direction ng east-west. So we have 1, 2, 3, 4 bars, no? So yung ating bars, so depende yan kung ilan yung ating development plan dito. So, kailangan yung ating bars is abot siya hanggang doon sa ating critical region or critical section. Then, with 8 legs crossing the critical section. So, ito yung ating, ito yung ating critical section. No? So, itong 8 legs, so itong 1, 2 legs plus 3, 4 legs, then another 5, 6 legs, and 7 and 8 legs crossing the critical section. Kasi ito yung critical section, so it should cross no yung ating reinforcement dito. Then the necessary area per bar is 2.02 square inches divided by 8 kasi 8 yung ating legs no, 1, 2, 3, 4, 5, 6, 7, 8, no? So that it should be 0.25 square inches. So we will use number 5 bars dito. So diameter na or the area of number 5 bars is actually 0.31 square inches. And the upper limit of our Vn should be equal to 6 times the square root of prime C BO times D. And this is automatically satisfied in this case given the more stringent limit on Vs. Kasi yung Vs natin kanina is less than the maximum Vs. So ito na ngayon yung ating design no, for the sample problem. So ito yung ating, suppose this is our east-west. Change ko muna yung color. So this is our east-west direction. We are looking at the elevation view. So hindi tayo naka-top view. So sa east-west direction, so ganito yung arrangement ng ating reinforcement bar. And also in the north-south direction, itong bar na to dalawa is also arranged in this or it is bent in this manner also, no? Katulad nitong bent bars dito sa east-west na nakikita nyo sa east-west direction. So if you're looking doon naman sa north-south direction, ito naman yung makikita nyong bent bars sa north-south direction. And then ito naman yung bars na makikita nyo sa east-west direction. Now, we have here the column with a section of 18 inches by 18 inches. So, ang width ng ating column dito is 18 inches plus this is so this is d over 2. So 18 inches plus 3 inches plus 3 inches is 24 inches. Ito yung first critical section. No, ito yung first na BO natin. And then we have here the second critical section, which is from the first critical section is 4.5, no? 4.5 inches and 4.5 inches. So, paano na kung 4.5 inches? So, in the next slide is makikita nyo kung paano nakuha yung 4.5 inches, no? So, given this second critical section, so 24 inches plus 4.5 plus 4.5 is 33 inches. So, we will look into this. Tingnan natin kung sa portion na ba ito ng second critical section is ano na yung magiging condition ng ating shear strength design, kung maglalagay pa ba tayo ng shear reinforcement or no need for shear reinforcement in this critical region, no? So converting 24 inches to feet is we have here 2 feet for the 24 inches. And for the 33 inches, we have 2.75 feet, no? So, ang ating total thickness is 7.5 inches and our effective depth is 6 inches. Now, so with bars bent at 45 degrees and effective through the center 3/4 of the inclined length, the next critical section is approximately 3/4 times the effective depth or 4.5 inches. So 3/4 of 6 is 4.5 inches. So yun yung ating next critical section past the first. So as shown, giving a shear perimeter of 33 times 4. So ito na yung bagong BO doon sa second critical section dito. So we have BO equals 30 times 4 or 132 inches. Then the factor shear at that critical section. So magko-compute na naman tayo ulit ng factor shear at that critical section. So meron tayo ditong BU is equal to 300 pound per square foot times the gross area minus the new itong 2.75 yung second critical section. So yun naman yung ating ibabawas mo. So 2.75 square. So we have here 117,700 pounds for the factored shear. So in the second critical section, then let's try to find out the design capacity of the concrete. So ito lang muna yung ating i-compute, no, yung wala pa yung shear reinforcement. So we will compare this one, the result of this, with the VU. So if this is greater than VU, then tingnan natin. So substituting the values we have here, 150,000 pounds, which is greater than the VU. So ang ibig sabihin niyan ay so no need for additional bent bars na kasi mas malaki yung ating design shear strength kaysa doon sa backward shear. So we don't need another or additional bent bars. So the number 5 bars will be extended along the bottom of the slab, the full development length of 24 inches as shown in figure 13.21. So since ito yung ating shear reinforcement, no, dito sa ating ito yung nagpo-provide ng shear reinforcement. So dito sa ating BO na 24 inches, this is bent dyan. And pagdating naman dito sa critical section is no need for the shear reinforcement na dito based on the calculations. So pwede na lang ito siyang extend doon sa ating bottom bars, no? Yan, ito yung ating bent bars. For shear reinforcement. Ayan. So, ang ating reinforcement is extended along dito sa critical section or first critical section with this perimeter 34 inches, no? Or perimeter to from the base of the support. So, nandito na lang ating part 1. So, we will discuss part 2 in the next slide.